Hello, everybody. We are today to make a classic database of geochemistry. Introducing such a video, then it is mainly to introduce the above 7 database. The first one is GeoROC, a very classic database. So, it's mainly contains magmatic rocks, metamorphic rocks, and minerals. There were more than 2 million such records. And the second one is EarthGen. It could be said that the entire geoscience industry. It's a pretty big database. It consists mainly of magmatic rocks, metamorphic rocks, sedimentary rocks, and minerals. It's got multiple databases. As a full stack of such a data platform, integrated like GeoRock, PTDB, and so on. What about one of its datasets? Actually achieved 40 million. That's an order of magnitude. And the third one is PTDB. Well, it mainly consists of magmatic rocks, a data of metamorphic rocks and minerals, mainly doing the samples from the ocean. Contains some data on chemical composition and mineralogy. Well, the fourth one is SGP. It is a relatively new database, so it's mainly for sedimentary rock data. The volume of its data reached more than 2 million, an order of magnitude of such an analysis result. It mainly does Paleozoic and Neoproterozoic sedimentary geochemical data. The fifth one is macrostrat. It mainly makes sedimentary rocks, igneous and metamorphic rocks. Such a data collection and entry. There are more than 2.3 million units of basic geological map data, mainly global-scale sedimentary rocks, igneous and metamorphic rock assemblages, including quantitative spatial and geological dating. The sixth one is minted. This is very well known in mineralogy. It actually includes mineral species. It can be said to be a very multifaceted introductio, including all kinds of minerals. Some data like crystallography, including some data on chemical composition. Also the sampling locatio, sample source. It's actually mineralogy. Very, very authoritative and a very comprehensive database. And the last one. Here it is. Pangea. One such field in earth and environmental science. It's sort of a data publisher, because it includes users can upload their own data. Users can also share it directly in it. Then other users can search. So it is like a data platform like the community. And the amount of data is also very large. There are more than 30.2 billion data results. So it's mainly for archiving. There is a bit of a property like the Zenodo platform. Then it can also be used for publishing. It's you uploading your data. It's distributed. It's disseminated. One such statistic from the earth and environmental sciences industry. So, we will take a look at the websites of these databases one by one. At the same time, let's introduce how it works, how to retrieve and download our data. Then the first one, let's take a look at the GeoRock database first. What about this database? In fact, it was created in 2000 years, developed by the Max Planck Institute of Chemistry. Recent years, the server of entire database has been migrated to the University of Göttingen for subsequent maintenance and development. What about the entire database? It can actually be regarded as one of the most classic databases in geochemistry. It has been collected so far. It has a specific amount of data here. There are 20,000 many articles. It also contains 680,000 samples. Its entire analytical record is an order of magnitude. It has reached more than 2 million. Such an order of magnitude. This data has actually been updated now. In fact, there is still a little discrepancy with the data table. That data table was calculated a few months ago, so its data volume has been updated to a certain extent. How about on the left side? Then we can see the first one. It's searching such a menu. Let's click in. You can follow different categories. Then you can choose the one you want. Way to search. Come and go for a user customization. Like what? Then I might just want to use the chemical composition to search. There also has different kinds here. For example, one of your standard values. So, what literature did you refer to? Then I will choose one of them. Then you can choose now. You want to set the range of such a one. Chemical composition. Then I set it up. Screening by aluminum content. Then we can set it up here. Highest and lowest values. And then the whole unit is unified. The main amount is unified, and then the trace amount is unified. Is to set this 1020. And then what about him now? We'll jump to our data retrieval results page. Probably retrieved 350,000 samples. Its aluminum content is between 1020. But because the amount of data is relatively large, so it may take a while. Then I'll change it. Let's change to a search with a smaller amount of data. We searched over 7,000 samples. Then you can proceed with the next step of customization. So, for example, you might want to. Some constraints are also imposed on other elements. Then you tell me to choose one. Trace elements. Restrictio. Then you want some specific sample sources. Let's say I want igneous rocks. Tits is the captive I want for the metal. All such rock types will do. Then you want the full rock. Do you still want inclusions? Either way. Volcanic glass is okay. Then include one of its. A limitation of the geological environment. Then I choose. Pick one. Then he will jump to the next one. Search results. Then we actually load it out. 816. Some desired locations. Then I don't make a specific choice. I look directly. Pick one. The first one. But it should be possible to choose more than one. And here we are. So you want a standard watch header. Still want custom, like not wanting that much data. Don't want so many data columns. Then you can choose. I just want geolocation information. Then just ask for age information. Tits is fine. I can download the data file. Let's open it up and take a look. It's a data result that we unlock. The data results include sample informatio, and sources of information in the literature, but in the same data table. So there he is in the literature. Sources of literature informatio. Then TITS is the following specific one. Source literature. Then we'll see some others, like TITS 1. That is, you can, according to the type of a sample, to do a screening. The content of minerals and rocks, or directly by the name of the rock. Or is it the name of the sample? Pick a clinopyroxene. Then this is okay. This is actually equivalent to a topic. A topic comes out like this. Then this is clinopyroxene data from this article. Choose a few. Oak. Then choose some. Chemical composition data. That. Standard output. And this is what he output. What about the ingredients? It's also only the few we just chose. Elements, what if you want more? You can actually choose all of them. And this is one of the search methods. Then we see another one below, precompiled file. So let's click this precompiled file. It's basically a database of data, according to different such indicators. What to classify. So let's say we look at it according to a sample of minerals was classified. What is it like? You see, it's actually, the data is sorted by mineral, one file at a time. This way you will find it faster. But the degree of customization will be relatively low. And then there is classification of rocks. Then the classification of intrusions. There is also a classification by locatio, according to Crotto, according to some other rocks, volcanoes, these different geological environments to carry out. Then we can also see there is original data of the sample. Here it is. This is one of the samples, a document of references. Here are some other raw data files. And what do we mean by raw data? In fact, it is to record this sample, a data of various informatio, including sources like data, test analysis method. There are also chemical components. Then sample the locatio. Wait for some records. Can be called the data of this sample. So here it is, precompiled, such a search. You can download it according to the category you want. This is actually very fast. We click one to download. So you can download it directly. Of a certain type of rock that has been precompiled, such a file. The header is also the standard header for the output. Contains this sample. All the contained informatio, like for example, geological environment, latitude and longitude, sampling locatio, and then some information about the sample. Then the color type of the source. And then there are some things, such as standard samples, and so on. There is also test information. its main quantity. Trace amounts are actually contained in this precompiled file. So, if you want to download all information about a certain type of sample, you can pass this precompiled port. To perform a search, this is relatively the fastest. This is GEOROC's expert database. In fact, it is based on the topic of certain documents. Maybe this person published an article. Then what about its article? It is a certain analysis of the data. How about this? It can be used as an expert database. Here it is. Global 1. Some analysis of the data of igneous rocks. And then 2021. A piece of data from this published article. As a whole database of experts. The data for this article is located here, and then, well, not much, just 12 featured papers. And also, say, minerals. Then there are rocks too. Then there are also like zircon database. Should be doing dating. There are also some samples like kimberlite. And then, so here's some of the data. Explain. And here's the key thing, because I had it before. The person in charge of this GeoRock has communicated. They actually want users, when using their data, to achieve it's a little bit more explicit to quote. Not just in the reference section. They used some of their more standardized citation formats. You can, for example, quote from this article, a document on the concept of a database. Then you can also quote like this. If you are using a certain data file, you can make a quote like this. Include you to record. What parameters do you use to filter? ENVA, like your rock name. Then you used basalt. And a filter of your geological environment, land, etc. You go and make an instruction like this. Then put it in your article. Then be able to make the data in this database better cited and recognized. This is what they would have done at the time. I hope users can do better. A point of practice. Okay, then we move on to the next one. Introduction to the database. Then it's Earthchem.
Nice.
然后这个呢，
And this is an Earthchem homepage. Then this database can actually be calculated. Geochemistry, the largest data platform. The main thing is a full stack data platform. Integrated, including like PTDB-SEDDB, Nav Audit, and USGS. Some databases, such as GeoRock, what about when you search for data in there? So many databases can be directly retrieved. Integrated data. And what about the whole data it contains, like principal quantity and trace isotope analysis? Then the analysis of the minerals is in situ analysis. Then the analysis data of melt inclusions are available. At the same time, in addition to downloading here is also upload port. If uploaded, there will be some such as rules and some restrictions of the template. At the same time, published something like what we saw. Template of data, dictionary tables of data, etc., some specifications. Then, and this will be more convenient, after uploading the data, it can go faster. Enter into the database. This is as a little bit of a standardized process. Then there are 3 such homepages. About all. Then you can choose what you want. Retrieved a database. Look up here. In fact, you can directly click here, enter pet, and then, of course, we can also enter this library. 1. Keywords for providing samples. Then the source community. Data type. So, if you want to retrieve data from a single database, you can start from. You just click the PETDB icon to come in. PETDB's search method is relatively direct. Geographical locatio. You can choose here. You can directly draw a map you want. Draw an area on the map. Or you can pass a numerical constraint on latitude and longitude. Then you can also directly to write a more accurate value of your latitude and longitude. Either way. And then is through. Sample characteristics. Use the source of the sample, like the OSHA, terrestrial, or some kind of craton, etc., etc. Some indicators of, that is, we choose craton now. Which samples of cratons do you want? Add to the right and click Submit. If you want all the cratons, then click Add All. The one on the right will come out. Retrieve sample. Approximate amount of data. General situatio. Then you can download the data here. Or rather, take a look at the map of your sample distributio. Retrieve results. Where are the main locations of sample distributio? Include references. You can also customize some of your output options. And then there are also types like samples. Then the chemical compositio, geological environment. Then some search methods, such as age. Then inside the igneous rock. Like what? Just want basalt. Just edit. Then go and retrieve a data of the basalt. 500 items were retrieved. We can download your data. You downloaded it. You can choose what you want. Rock samples or mineral sample data. Still want inclusion sample. Rock sample. You can now choose which ones you want to output. Element. This is the element of the sample. Then I'm all marked. Select all. If you don't want this watch header to be too long, so can you select certain output items. You can look at a pattern of data. A very, very long one can be downloaded. Downloaded into formats. One is an Excel file and the other is a TXT. We'll let you choose your purpose. Include some citations, some detailed views, some data descriptions of the database. This database and GEOROC. One big difference is that it will take the data and its source literature, divide into two subtables. Then what about the data table header? There will be a slight difference. Contained I. Sample informatio. The properties will be slightly different. Then I will tell you when I download it. Output time. There is a timestamp in this form. This, I think it's better and more accurate. Of course, you can also search other databases. And then, this is some data, some platform content. So, I'm going to focus on this. 1. Geochemistry. This is an organization, and what they're mostly doing now is hoping to build some geochemical industry standards, or put some geochemical ones like this. Different platforms, or organization, or institution, or official publisher. Researcher group. Let's do a joint construction together, including some industry standards and some rules for data distribution. To do such a unification, or something that's standardized. This is also one he submitted. Page Introductio. He will have a submission process like this. Well, there are more of them. Confirm, for example, whether the data has a DOI. Then does your sample have an IGSN number? Such steps. You can also choose from here. Enter your search. Earthchem portal. Integrated platform. Then this integrated platform and library. Slightly different. Then in this integrated platform you go in and you call. Let's say I want to search by keyword. The interface is slightly different, but the options provided are about the same. According to the reference, do a screening, or fill in, for example, the author. Then the title. Then the journal name, DOI number, to filter the data corresponding to some references. Then include some like keywords, but it's not limited to what type of keywords. You can also enter an element name, then some geographical location, and so on. Geological environment. Some keywords like this are okay. This is the general situation of Earthchem. And then PET. In fact, its search method has just been introduced. What about PTDBTs actually? 2,000 years to start. Put into use. He actually started with Georock. Started in the same period. But what they did was they sampled the ocean. One did terrestrial prototypes. Georock is for land samples and the PTDB mainly does marine samples. And PTDB is currently at Columbia University to perform this maintenance. And then, I don't know if he is still there, continuously update its data. But recently, he probably isn't updating the data at all, maybe in 2013 or a few years. At that time, the data volume will be updated a little more frequently. Now it will be a little bit. It should be regarded as maintenance, not very ordinary. And then, check out some other content on this website. We can see from its references. What literature data did he collect? He actually collected data from over 3,000 articles. You can conduct a search of these documents. Data to goal. Equivalent to. Compile some data files. For example, he compiled the 2019 such A1 data files, all from 2019, different types of data files. After pre-compilation, you can directly click to download. In fact, the server is equivalent to being stored in Earthgen. So, let's move on to the next database. What about its full name? It's actually called the Sedimentary Geochemistry and Paleoenvirons Project. It's a sedimentary geochemistry and paleoenvironment database. Well, it is actually led by Stanford University. Such a database, including the Paleozoic and Neoproterozoic periods on a global scale. Data on sedimentary geochemistry. So, he goes through different phases to do such a data release. So far, he's released the first phase of the data. The second stage data has also been released. Click to see. Then there is one on its homepage. Click the search button to search directly. Its second stage. The second version of the data has been released. And this is one of its search boxes. It's divided into 3 parts. One is simple search. The second one is a little bit more detailed. He mainly provides this age and the geography. There are some elements of customization. Contains isotopes, then major elements and trace elements. I have some other information. Reference information can also be customized. Some more detailed references. It is relatively simple or only requires a DOI number. A more detailed search provides more customization, like the source of the data. In fact, it also integrates different ones. Database data. I mean these data source projects. He is according to literature to distinguish as a project. Include some screening on chemical composition. A test method has also been added. I'm talking about references. Then this filter is mainly let the testing method, analysis method to do a screening, including what kind of analysis method, and then some samples of experimental methods, etc. The lab. It can also be used as a distinctio. Include a provider of data. Can be used as a filter for him. The part of this show is when you demonstrate. It's what you want when you download it, your data. Contains some information. These are also parts of the show. These also have. Then it's simple filters or your samples. Some conditions for screening, like the source of the sample, collector. And then analyte filters. It's chemical composition to do a screening. Then customize these. The part you showed. What information do you want when you download it? Then click Search at the end, and its file will appear. This is the sample we selected. Then click Login to download. But the output is CSV software. This is the sample we retrieved. Of course, I didn't really have a lot of options just now. He wants to export information. Therefore, the columns of its file are relatively small. If you want to enter a lot, part of the show, choose More. Choose what you want. But this one doesn't. There is no button to select all. The design can be slightly optimized. Then he will increase these ingredients we just screened. Easy to download. Well, then we introduce the next one. Macrostrate. Here it is. A database of sedimentary geochemistry. It's a team from the University of Wisconsin to create a global-scale sedimentology database. It mainly includes subsurface sedimentary rock. Then there are also some igneous and metamorphic rocks. Combination to carry out quantitative spatial and geological chronological analysis of data. And what about the amount of data it has now? A relatively large order of magnitude. There are already more than 2.5 million geological map units. Then this data fee has been updated. There are also units of rock. 30,000 more. Here we go. Search it and take a look. It is divided by region. Clicking to enter will display existing data points. Here are some. Specific. Filter. This should be according to some screening of paleontology. So a map of the distribution. Then there are some information. In fact, it is mainly a global Information on the distribution of sedimentary rocks. Here's a three-dimensional visualization. And this is a really silky model. Here are some of its filters. Layers. This should be something specific about it. Data. Data point. Click on the colored dot. At this point only. So many samples. However, its source is also available. Sample type, age, etc. There is information about the environment. And let's move on to the next one. MinDAT's Mineralogy Database.
Detail.
What about this database? It's just pure mineralogy. And then we can see its database. It is now included. More than 6,000 minerals. More than 3,000. Rock. Here's a few more. It has not been officially defined. Name of sample type. Locatio. Location information is 410,000 locations. Then look at it from minerals. What about this database? It was actually established by the Hudson Mineral Institute, so it is one of the largest mineral databases in the world, focusing on making minerals, rock meteorites, and their origin in formatio. They're actually working on a project right now. It's called OpenMinDat. To go is to do one. Machine interface for data access. And then, it is convenient for users to go faster, retrieve data from a database, then deal with it more efficiently. Well, feel free to order one. Then we choose 11 here. Click on this mineral species to go in and see it. What information will there be? And the first thing we can see is this webpage. It showed some pictures of quartz. Well, including some specific categories. Smoke crystal and amethyst. Some photos. Pink crystal. Then here are the parameters. Then include the chemical compositio, chemical formula, color. What are the types? Hardness. And then specific gravity, crystal system. Here they are. Some parameters related to crystallography. And then are there some samples above? One is like a single crystal. And then some of the cryptocrystals, like agate, for example. These chalcedony, it's cryptocrystalline. And here's a single crystal. This is mainly due to the difference in its growth structure. Some specific descriptions of its crystal structure. The molecular arrangement. Crystallography is very informative. And here is the crystallographic information. And then down there is it. Introduction to some types of colored crystals, namely trace element color. for example, such as smoke crystal and amethyst. Agate has a ring-shaped structure. Something different. Introduction of types. Include some identifying characteristics of the sample. And here it is. Some definitions of mineralogy. A definition of EMA. Introduction to some references. Some introduction to the definition of this mineral. And the pronunciation of this word. And then some introduction to physical properties. And here's its optical data. Refractive index, and then spectrum. Chemical compositio. For example, there may be some impurity elements. Then age. The recorded age is probably in the range. Then some data from crystallography. So, let's say we have a space group. Unique cell parameter. There are also double crystal types. This is one of the crystal structures. File. 3D file. This time the crystal structure. Here are some parameters of XRD. Unique cell parameter. That data should include it can download files. A spectrum of X-ray diffractio. This is in the rough database. Introduction to some geological environments. Included in different languages. The name of the sample. It should be the introduction of different kinds. This is very complete for information on a mineral species. It's very, very comprehensive. Then quartz. Relation to other mineral species. Seasite, etc. Some related minerals. Some other informatio. Some information on petrology. For example, it exists some of the igneous rocks. In those rocks such as sedimentary rocks. Introduce. Then some introductions on the internet, like Google entry. Then the entry on Bing. Wait for some introductions, or some literature related to quartz. Some are older, some of the more classic literature. Then you can click to jump to this file. Go to the specific page to download. And then, this is basically everything about minerals is fresh, very complete, very kind. Mineral types are also basically a lot more. Then if you want the mineral, the properties of a certain mineral, have a very comprehensive understanding, then this website is actually very suitable for. Then the next database, called PANGAA, by the Alfred Wegener Institute and Helmholtz Center for Polar and Ocean Research, and the University of Bremen, jointly established by the Marine Environmental Science Research Center. It originated from CEDAT, established in 1987. Renamed in 2010. Current name. And then for archiving and publishing and distribution. Data from Earth Sciences and Environmental Sciences. So, here's a breakdown of some of its data, classified by chemical compositio. And then some other categories, geophysics, etc. Some classifications of the surface. Ecology OSHA. Classify the data. Let's click in and have a look. Chemical classification. We can choose these data. Age of source. Which projects do they belong to? Test methods, etc. And then geolocation, and so on. Then go to search. And the author, choose an author. Also according to the article. To carry out a whole. Include and classify. But the type of information in this database is very comprehensive. Provide the distribution of the map of the data. Some more detailed parameters of the data. Download. The download format will be slightly more. This different encoding type can choose what you want. This is the information of its data. Today's database introduction video ends here. Hope to be able to have some help and understanding for everyone.